Right, let's have a look at this one here. You've got Z1 is S plus 8i, I think, and Z2 is T plus 8i, and the modulus of Z1 is 10. Find the possible values of S. Okay, so the modulus of Z1 will be square root S squared plus 8 squared. That should equal 10. So if you square everything, that's S squared plus 64 should equal 100. So that means S squared equals 36, which means S equals plus or minus 6. And now the argument of Z2. Okay. So the argument of Z2, that's equal to 3 pi over 4. So that would mean then that tan 3 pi over 4, that's equal to 8 over t, imaginary over real components. So I'll be a bit lazy and just use my calculator. Tan 3 pi over 4 is minus 1. So minus 1 equals 8 over t, which means that t is equal to minus 8. Find the values of S, find the value of t. Use de Morgan's theorem to find in polar form the 5 roots of Z5 equal 1. So we write the number 1 in polar form, which is extremely easy to do. It's just going to be cos 0 degrees plus I sine 0 degrees. Cos of 0 plus I sine of 0. That's 1 in polar form. It's kind of worth remembering that. In general polar form, we have to add in 360 degrees times n plus 360 degrees times n into the angles. Oops. 0 plus 360n and 0 plus 360n. And we'll have to put a fifth root on both sides to cancel the 5. And de Morgan says that the power multiplies here the angles, so that becomes cos 360 over 5, which that's 72, isn't it? Yeah, 72. So that would be 72n plus I sine 72 degrees times n. Okay, and then we just have to calculate the 5 roots, and in fact we can leave them in polar form. So Z0, n is 0, that would be 1 plus 0. Oh, actually, sorry, leave it in polar form. That would be cos 0 plus I sine 0. Z1 equals cos 72 plus I sine 72 degrees. Z2 is cos 144 plus I sine 144. Z3 and then Z4. So Z3, getting tired. 216 plus I sine 216, and then finally 288. Cos 288 degrees plus I sine 288 degrees. Okay. Choose one of the roots, except the first one, and prove that w squared plus w cubed is real. Okay. So which would be the nicest one? Can't choose the first one. Maybe I'll just go with choosing this one to be called W. Okay, so W squared plus W cubed, that will equal cos 72 times 2, because De Morgan says powers multiply the angles, plus I sine 72 times 2. And then I'll write that a little neater. Cos 72 times 2 plus I sine 72 times 2 plus cos 72 degrees times 3 plus I sine 72 degrees times 3. So that's the W squared and that's the W cubed using De Morgan's to calculate the powers. So that's cos 144 degrees plus cos 216 degrees plus I sine 144 degrees plus I sine 216 degrees. Sadly, my sines didn't cancel. Oh, hang on. Yes, they do cancel. I was in the wrong mode. So these two guys are the same, but just opposite in sign. Yeah, they're the same, but just opposite in sign. So they actually cancel. So you're just left with cos 144 degrees plus cos 216 degrees then. Yeah. I mean, we could prove that these cancel without having to use the calculator if we really need to. Perhaps we should. Sine 144 and sine 216. So for anybody who needs to see it, sine 144 plus sine 216. Sine 144 plus sine 216. So this would equal sine 180 minus 36 plus sine 180 plus 36. So that would equal sine A cos B minus sine B cos A plus sine A cos B plus sine B cos A. cos of 180, that's minus 1, and sine of 180 is 0. So you would be left with sine 36 minus sine 36, which is 0. So if you don't have a calculator, or you want to prove it without using a calculator, there you go.